Hello, we're going to be looking at Boolean algebra as a topic in the next few videos. It's going to sort of build up fairly steadily. So let's look at some of the kind of fundamentals required to understand this topic. So when we're talking about Boolean values, we're talking about values which are either true or false. And an important term to get familiar with is the term Boolean expression. A Boolean expression is a combination of values and operators, but they are always going to evaluate to either true or false. For example, we use them a lot in programming with if statements and while loops in particular. Here is part of an if statement. I've got a Boolean, what we might call a Boolean condition. This is really also called a Boolean expression because this middle part is going to evaluate to either true or false. What it evaluates to will depend on the values of age and has car. Now, despite this being how we often see this in programming, within this topic, we tend to simplify this a lot further by just using letters as placeholders for variables. So you can see has car is likely a Boolean variable anyway, and I've replaced that with B. Age is greater than or equal to 17 isn't a Boolean variable. Age is likely to be an integer, for example. However, for the purposes of this topic, we will simplify this to be effectively a variable. We always use single letters here. The actual letters don't really matter, but the letters represent a Boolean variable because age might be 17, 19, 25. That might vary, but this expression itself, age is greater than or equal to 17, is either going to be true or false. Therefore, I can simplify it to be a letter representing either true or false. And the output is given a letter as well, because the output is either going to be true or false. Often Q is used as the output, but it could vary a little bit. And the purpose of us simplifying it is so that we can more easily understand what combinations there are going to be. And we often show the combinations in a truth table. The truth table is a method of representing every possible output based on the inputs to a Boolean expression. A and B here are the two inputs. Q, in this particular example, is our output. And here I've got a truth table. I've got my inputs as the first couple of columns and my output as the last column. And it's showing all of the combinations. So A and B could both be false. A could be false, B could be true. A could be true, B could be false, or both could be true. These are the four possible combinations in this simple expression. And depending on these values, Q is going to be these values here. One of the reasons we use Boolean as a data type is because it maps really cleanly to binary. So Boolean values can be written either as true or false, or T and F, or also 1 and 0. True is 1, 0 is false. This is a perfectly valid way of representing a truth table. In fact, I prefer zeros and ones. It makes more sense to me. So we've got four fundamental Boolean operators to understand. Not is our simplest, it's also called negation. So not will take in one input and reverse it. So here is a simple Boolean expression, not A is equal to Q. Well, what are the possible values of A? Because A is Boolean, it's either going to be false, 0, or true, 1. Not flips it, so makes 0, 1, and 1 and 0. Instead of writing out the word not, we more often will use this symbol here. So this symbol hasn't really got a name. The name is not. I don't even know how to describe it really, but that symbol is how we write not quite often. We also occasionally will see a bar over the top of our letter. This isn't how OCR will represent things in exam questions. So you've got to be much more familiar with this top one. You may also see this bottom one as well. The next operator to look at is OR. This is also called disjunction and returns true if either of the inputs are true. Inputs plural because I've got two inputs with OR. It will only return false if both inputs are false. And we can see in our truth table, Q is only 0 when both inputs are 0. So OR is very accepting. The alternative symbol is like a V. It's not officially a V, but it's a little bit smaller than a V, but it looks like a V and you draw it like a V. That is our symbol for OR. And one you may also see, but you wouldn't necessarily use in an exam, is a plus. So we use a plus because it's kind of doing addition. 0 plus 0 is 0, 0 plus 1 is 1. 1 plus 1 is 2, so it doesn't quite work in that last case, but it's doing similar to addition. And actually its kind of cousin operator is really doing binary addition. This is XOR. XOR is a slightly stricter version of OR. This is called exclusive disjunction. It's using the same word disjunction, but is exclusive, it's more strict. This returns true if one of the inputs is true. So our truth table is the same as OR, except our bottom row, when both inputs are 1, this is 0, because it doesn't like when both inputs are 1. The alternative symbol is the little V with an underline this time. That represents XOR, and The super alternative symbol is a plus with a circle around it as well. And the last fundamental operator to look at is AND. So this is called conjunction. And this returns true if both inputs are true, otherwise the result is false. So AND is our strictest one. It's only true if both inputs are true. And the symbol is an upturned V, but it also can be written as a full stop. This full stop is representing multiplication. So OR and XOR are doing forms of addition. This is doing multiplication. We can see that in the table, 0 times 0 is 0, 0 times 1 is 0, 1 times 1 is 1. And the fact that XOR or OR are like addition and is like multiplication affects our order of operations. We have these in normal maths where something like this, the answer depends on whether you are following the order of operations. We multiply before we add. So I'll do 2 times 4 is 8, plus 5 is 13 because of the order of operations. We have the same in Boolean algebra. Like in maths, brackets would get evaluated first. Evaluated means, carried out. We check brackets first. Then, in terms of our operators, not is done first. Then it follows normal maths. So AND is done afterwards, AND be multiplication, then XOR, then OR, which are the two addition ones. You have to also memorize that fact because that occasionally will come into Boolean algebra questions.